what we're going to do here is we're going to continue with the class problem, okay? And what we'd like you to do is tell us what the pressure at the pivot point needs to be for the system that you're designing, all right? We've already got a flow rate now. Yeah.
I'm sorry, can I ask a question about
Sure.
this example?
Yep.
So would it be a good rule of thumb to say that if you're going to try to reduce the diameter of the pipe to help save the producer money, it needs to be at least half of the distance of the total system? Or where is kind of the cutoff for you to realize some value in pressure loss?
Yeah, that's a great question. I don't have a rule of thumb on that one. You know, usually it's the computer that's designing it, and they'll try to optimize those things. You know, and it really depends on what assumptions they're making.
Okay.
But obviously, you know, the more larger diameter pipe you have, two things go on. It's more expensive, or you have less friction loss. So then that's where you have the balance, and it's like, well, how much does a pipe cost, and how much does the pressure cost us? So, but I don't have a rule of thumb.
Okay.
All right, so determining the pressure at the pivot. So what we're going to do is let's go over this equation, and then I'm going to set you loose to do it on your problem, okay, on your class problem. At this point for your class problem, do you have the length of your pivot, the length of your lateral?
Yes.
Okay. I think that would be, well, you have the acres, right? And we didn't have you listed, but somewhere, if it's a circle, you can figure it out. If it was like a half circle or windshield wiper, you should be able to tell us what the length of your center pivot lateral is, right? And now that you have the Q, okay, what else do we need to know in order to figure out what the friction loss is along that? We have the length. We're going to say it's epoxy coated, so we have our C. I think we're done. And I think you can figure out what the friction loss is.
Yeah.
We want to make sure that we get the correct amount of pressure at the end, right? So what we want you to do is tell us what is the pressure that you need at the end. Claire, should they assume it's a flat field, or is this a different
20
field?
feet of elevation and 15 pounds at the end.
Okay, perfect. Was that given already? Or just, okay.
What was that again?
Yeah. Claire, what was that again?
20 feet of elevation difference.
So we have 20 feet is our elevation change. And can we be more precise, Claire? Is that from the pivot point to the end?
Yeah.
Okay, so that's from the pivot point to the end. The most it's going to go is, it's kind of like today, we started, it was a higher location when we started walking down to the pivot point. So that would be like the worst case scenario. We want to make sure that we can get water up that hill, and not just water up that hill, but at a certain pressure. And what is the pressure that we need?
15 pounds.
15 psi.
That's probably 90% of the pivots nowadays.
Okay, is we want it every nozzle, but what you're going to do is make sure we have it at the end nozzle when it's going uphill, right? Because that's like our worst case scenario. All right. And I think you can pivot point. What do I mean? All right, and I can draw a picture. I've got this pivot that looks like this, right? Kind of, sort of. All right, and then we have our lateral going off. And just like today, we had water coming up here. Where's the pivot point? All right. When I say that, I mean, is it down here? Is it up there? Where is it? Okay, and why do you say the base?
You have to have some date on some starting point. That's an easy one.
Sure, yeah, makes perfect sense. But here's the reality, is that if they don't tell you, when I say they, whoever's talking about pressure at the pivot point, I mean, is there a difference, if this is 13 feet elevation difference, now we're talking about what, 5 pounds of pressure difference. That can be an important point. So make sure you're clear on what it is. And the reason I even bring this up, I mean, there's a couple reasons, but the way we're going to look at CPED tomorrow, which is the program to evaluate center pivots, and their pivot point is right there, which is weird. The nozzle height translated back to the pivot point. I mean, there's a reason they do that, but it's just flat out strange. That's the way they do it. So let's just...
A lot of pivots you'll see a pressure gauge mounted at the sprinkler height.
Yeah. So maybe that's why. Yeah, because it's something you can verify. But for this exercise, let's have it, our pressure at the pivot point is at the base, okay? Just so everybody's clear, all right? I mean, we could choose it anywhere, you know. I mean, we could choose it up top, we could choose it here, we could choose it here. But let's say that I have a pressure gauge right there as that pipe is coming in, and that's my pivot point. Just so that we're all working from the same datum, pivot point. Okay, that's the ground elevation where that is. Let's just make it, well, we'll make it 13 feet. Okay, our height of our pivot is 13 feet. All right. And your nozzle is 9 feet above the ground. So that last nozzle is 9 feet above the ground. All right.
Peter,
Yeah.
I was asked a very good question here.
Sure.
As far as nozzle heights, that is something that can be specified mainly by location, type of pivot, and the crop you're growing. Okay? And we'll get into that a little more in the next section, but it does not have to be at 9 feet. It does not have to be at 1.5 feet. It can be anywhere in between.
Could be on top.
Be on top. The thing you have to realize is, the lower it is, the closer the nozzles have to be together. So, there is some definite leaning towards the lower ones now, the Lisa Leica type, and then again, we'll talk about it in a minute. But, finish up this.
Okay, so again, you know, we're going to continue the class problem. You've got a cue, you've got hopefully a length for your lateral. Tell us what the pressure at the pivot point is. All right. Now, you are going to have to determine, you're going to have to make your determination of what the center pivot lateral diameter is. That's your choice, okay? I would expect you to choose something that's normal, all right? If you say, well, I want a 3-inch, or, you know, if one that's like pi diameter of 3.1416, I'd say it's possible, but you'd have to have a lot of money to get that. So use a common diameter, and don't sweat it too much. Just pick a number. If you want to do two diameters, you can do that, but that would be extra work. Just pick a number and then figure out what the friction loss is, calculate back to the pivot point. And if you have any questions, raise your hand. If it's not clear what I'm asking you to do, raise your hand. Okay?